We'll continue with the sums from exercise 16b. Let's go to question number 8. Angle PQR is equal to PST is equal to 90 degree. Both are 90 degree. The measurement of the sides I have written. You have to prove that triangle PQR is similar to triangle PST. So first one, in triangle PQR and triangle PST. First, what information is given? Both are 90 degrees. So angle PQR is equal to angle PST is equal to 90 degrees. This is given in the question. Now, the next part, in both the triangles, in this triangle and in this triangle, angle P is common. So, angle P is equal to angle P, common angle. So, therefore, these two triangles, therefore, triangle PQR is similar to triangle PST by axiom test of similarity. So, we have already proved the first sub question. Now, second one, find area of triangle PQR upon ratio of area of quadrilateral SRQT. But finding SRQT, I need this smaller triangle also. So, first using the theorem, area of triangle PQR upon area of triangle PST. Okay, when you do this, what is it? We have proved it is similar triangles. So areas of two similar triangles is equal to or corresponding to the squares of their corresponding sides. So here PQ square and here PS square. Correct? What is PQ? PQ is 5 square and PS is 2 square. You will get 25 upon 4. This is area of triangle PQR upon area of triangle PST, which is equal to 25 upon 4. Remember earlier I told you, whenever you want to find the area of the quadrilateral or trapezium, what is the trick? You will subtract 1 on one side from both the sides. Secondly, the area of the bigger triangle should be in your numerator. Here PQR is a bigger triangle, it's already in the numerator. So let's find. So area of triangle PQR upon area of triangle PST, subtracting 1 from both the sides, is equal to 25 upon 4 minus 1. Okay, so what you will get? This will become area of triangle PQR, taking the LCM, minus area of triangle PST, the whole upon area of triangle PST is equal to 25 upon 4, here also minus 4. Okay, so this will become area of quadrilateral SRQT upon area of triangle PST is equal to 21 upon 4. This is your second equation. And what is your first equation? This is your first equation. What are we supposed to find? Area of triangle PQR. Here you have got PST. So first equation and second equation, you can use it to find this. You want this in the numerator and this in the denominator. So what you will do? This, when you divide with this, you will get the answer. See, area of triangle PQR upon area of triangle PST, when you divide it by area of quadrilateral SRQT upon area of triangle PST, which is equal to 25 upon 4 divided by 21 upon 4. Okay, so what you will get? So whenever you are dividing, you are taking the reciprocal. So area of triangle PQR upon area of triangle PST into area of triangle PST upon area of quadrilateral SRQT is equal to 25 upon 4 into 4 upon 21. 4 and 4 gets cancelled. this and this gets cancelled. What you needed? Area of triangle PQR is to quadrilateral this. The answer is 25 upon 21. I hope it's clear. Come on, let's go to the next question. Let's go to question number 9. In triangle PQR, L and M are 2 points on the base QR such that angle LPQ I have marked it, and QRP are equal. QRP. So these two angles are equal and these two angles are equal. Always differentiate whenever you are marking the angles. You have to prove that triangle PQL is similar to triangle RPM. First part. In triangle PQL and triangle RPM. First, PQL and RPM. These two angles are equal and these two angles are equal. So, it's already given in the question. LPQ is equal to QRP and RPM is equal to RQP. This is given in the question. Okay. So, if both the angles are equal, therefore triangle PQL is similar to triangle RPM by axiom test of similarity. This is your first subpart. Okay. Next one. QL into RM. QL into RM is equal to PL into PM. So these are all corresponding parts of this congruent similar triangles. So let's take, you want PQ? No, you want QL. So let's take PL upon RM is equal to, what else you need? You need PM and QL is equal to QL upon PM. What is this? This is PPT, or we can, not BPT, we can write in fact sides are proportional of similar triangle. Correct? Sides are proportional of similar triangles. So now cross multiply, you will get QL into RM is equal to PL into PM. This is proof. The second subpart. Third one is, you want PQ square is equal to QL. Let's understand how to do this. You want PQ square, okay, is equal to QL into QR. So which two triangles will you take? QL into QR. So you will take in triangle PQL, or easier way, you know the angles, right? You know the angles. It is LPQ which is given, LPQ and triangle QRP. Which two triangles I have taken? I have taken this bigger triangle and the smaller triangle. Why I have taken this? Because I wanted here to be QL into QR. So QL is part of this triangle and QR is part of a bigger triangle. Okay. Now, how will you prove this? What is given? Similarity is already proved. These two triangles are similar, right? PQL and RPM. RPM is proved. So let's prove this one. So here, this is already given. LPQ is equal to QRP. It is given in the question. Correct? Then, what else? LPQ and QRP. So angle Q is common. So therefore these two triangles are similar, common angle. Therefore triangle LPQ is similar to triangle QPRP by axiom test of similarity. Now let's solve it. What do you want? PQ. So let's take this PQ. PQ upon RP is equal to, what else you need? QL upon PQ. Right? QL upon PQ. Cross multiply. PQ square is equal to QL into RP. Proved. Clear? Let's go to question number 10. Medians BD. Median means D would be the midpoint for AC, and CE. So E would be the midpoint for AB. They meet at G. You have to prove that EGD is similar to triangle CGB. Let's do that. First, this is the midpoint, this is the midpoint. Okay. So, as per midpoint theorem, if there are two midpoints, what will happen? ED will be parallel to BC. You will write midpoint theorem. What was midpoint theorem? If one of the side has a midpoint and the other side of a triangle also has a midpoint, so this side will be parallel to this side. Okay, so ED is parallel to BC. Now what you have to prove? In triangle EGD and triangle CGB. Now this angle is equal to this angle, alternate angles, correct? And this angle is equal to this angle, vertically opposite angles. Come on, let's write it. Angle EDG is equal to angle EDG CBG, alternate angles. Then angle, vertically opposite angle, angle EGD is equal to angle CGB, vertically opposite angles. They are all equal. Okay. So therefore triangle EGD is similar to triangle CGB by a Axim test of similarity. The first part is done. Okay. So as per midpoint theorem also, this is done. So that means ED is half of BC. So 2ED is equal to BC. This is midpoint theorem. Midpoint theorem. Okay. Okay. Come on. Now you have to prove that BG is equal to 2 into GD. Let's take these two triangles only, since you have proved in triangle EGD and triangle CGB. Okay, you have proved these two triangles are similar. Now, what you want? You want BG. So, BG is here. So, GD upon GB is equal to, what else you need? What information is given? BC is given. BC is this, so you will take ED upon BC. Okay, so GD upon GB is equal to ED upon, what is BC? It is 2ED. 2ED. This and this gets cancelled. Now cross multiply. 2 into GD is equal to BG. This is what we were supposed to prove. I hope it's clear. Let's go to question number 11. PQRS is a parallelogram. What are the properties of a parallelogram? Opposite sides are equal and they are parallel. Okay. PQ side is given as 15, RQ is 10. L is a point on RP such that ratio of RL is to LP is 2:3. And QL produce meets here at M, here at N. You have to find the length of PN. You have to find the length of this PN. And you have to find the length of RM, this. Now, let's think. If I want to find this length, first I need to prove the similarity. Which two triangles will I take? The measurement of this side is given to you and this side is given to you. So, you can take this triangle and this triangle. See, the ratio is given and two lengths are given. So, we can find PN. Yes, let's prove this. In triangle RQL and triangle PNL. RQL and PNL. Okay. First, what is there? This is equal to this. Okay. Let's not take this. Instead, let's take this. They are alternate angles and this is a vertically opposite angles. So, angle QRL is equal to angle LPN. alternate angles. Then same way, angle RLQ is equal to PLN. What is the reason? Vertically opposite angles. Okay. So therefore, triangle RQL is similar to triangle PNL by AA. Two angles are there. So AA, axiom test of similarity. This part is clear. Now you have to find PN. Let's find PN using this. So RQ upon PN is equal to RL upon PL. LP. RQ is given as 10 upon PN is equal to RL. The ratio is given as 2:3. So what is the measurement for PN? PN is 10 into 3 divided by 2, which is 15 centimeter. Okay. Now we have to find RM. So RM is over here. So you will take this triangle and this triangle. Prove these two triangles similar first. So in triangle RLM and triangle PLQ. Okay. What is given? See, opposite sides are parallel. So this angle is equal to this angle. Alternate angle MRL is equal to LPQ. Alternate angles. Same way, this angle and this angle are vertically opposite angle. Angle RLM is equal to PLQ. Vertically opposite angles. Therefore, triangle RLM is similar to triangle PLQ by AA, axiom test of similarity. This is done. Now you have to find RM. Now you have to find RM. So RM upon PQ is equal to RL upon PL. RM you need to find. PQ is given as 15. RL is to this ratio is given as 2 upon 3. So now find RM. So RM would be 2 into 15 divided by 3. 3 5s are, so it is 10 centimeter. I hope it's clear, children. Yes? Let's go to question number 13. BC is parallel to DE. Area of triangle ABC is given. DE is given as 14 centimeter. Area of trapezium is given, which is 24. Find the length of BC. Okay, BC you have to find. So first what you will do, you will have to, these two sides are parallel. First you will prove triangle ABC is similar to triangle ADE. Come on. In triangle ABC and triangle ADE. Okay. Now angle A is common angle. Angle A is equal to angle A, common angle. Then this angle and this angle both are equal since the sides are parallel. Therefore, they are corresponding angle. Angle ABC is equal to angle ADE. Corresponding angles. Therefore, triangle ABC is similar to triangle ADE by AA, axiom test of similarity. Okay, this part is done. Now, trapezium area is given, small triangle area is given. So, you can find area of triangle ADE would be area of triangle ABC plus area of trapezium BCED, correct? Smaller triangle plus trapezium will give you a bigger triangle area. What is triangle ABC? 25 centimeter square plus 24 centimeter square. So area of triangle ADE is 49 centimeter square. Come on now, you can use the theorem. Area of triangle ABC upon area of triangle ADE is equal to BC square, and you will take here DE square. Area of two similar triangles are proportional to this side is given, so you will have to find BC, right? So what is ABC? It is 49. ABC is 25, sorry, and AD is 49 is equal to BC square upon DE is 14 square. So 25 upon 49 is equal to BC square upon 196. 14 square is 196. So BC square is 25 into 196 divided by 49. Okay. So this is BC square. What is BC? BC is square root of 25 into 196 upon 49. So what is the square root of 25? It is 5. Into what is the square root of 196? It is 14. Upon what is the square root of 49? It is 7. So 7 to the answer is 10 centimeter. Yes? Chalo, let's go to the next one. Started? Yes, let's go to question number 16. In triangle PQR, MN is parallel to QR and PM is to MQ is 2:3. You have to find MN and QR. So what will you do? First you will find which two triangles are similar. Which triangle will you take? You have to find MN and you have to find QR. So you will take PMN and PQR. Correct? So in triangle PMN and triangle PQR. First, angle P is common. Common angle. What else? Since these two sides are parallel, so this angle will be equal to this angle, right? Angle PMN is equal to angle PQR, corresponding angles. Therefore, triangle PMN is similar to triangle PQR by axiom test of similarity. This is done. What you want? MN is to QR. So let's find it. What information is given to you? PM and MQ is given to you. Okay. So let's do this. PM upon PQ is equal to MN upon QR. Correct? You have to find the value of this. What is PM? So PM would be 2 upon PQ is what? It is 2 plus 3. This ratio is already given. So it would be 2 upon 5. This is the first part of the question. Now we come to prove that triangle OMN is similar to triangle ORQ. So in triangle OMN and triangle ORQ. First, alternate angles OMN and ORQ. Angle MNO is equal to OQR, alternate angles. Also, you can take another alternate angles or you can take vertically opposite angles. Anything is fine. And angle MON is equal to ROQ, vertically opposite angles. Therefore, triangle OMN is similar to triangle ORQ by axiom test of similarity. Correct? We proved this. Now what? Find the area. Okay. So third part. Area of triangle OMN upon area of triangle ORQ. Area of two similar triangles is equal to the square of the corresponding sides. So OMN I can take MN square upon ORQ I can take QR square, which is equal to what is MN? You already found out, it is 2 upon 5. So 2 upon 5 the whole square. So area of triangle OMN upon area of triangle ORQ is equal to 4 upon 25 their square. This is your answer. Question number 17. PQR is a triangle. S is a point on side QR of triangle PQR such that angle PSR is equal to QPR. I have already written the sides. You have to prove that triangle PQR is similar to triangle SPR. So let's do that. In triangle PQR and triangle SPR. Now, what information is given to you? QPR is equal to PSR. This is given in the question. Okay. Now, if you take both this, angle R is common. So, angle R is equal to angle R, which is common angle. Correct? Therefore, triangle PQR is similar to triangle SPR by axiom test of similarity. I hope this part is clear. Come on. Now you have to find the length of QR and PS. Let's take what information is given from here. PQ upon PS is equal to QR upon PR is equal to PR upon SR. Sides are proportional, correct? Now you have to find QR. So you will take QR upon PR. Okay. Now what information is given to you? PR is given to you, SR is given to you. So use that, PR upon SR. So QR is, you have to find, PR is 6 is equal to PR is 6 and SR is 3. So QR is equal to 6 into 6 divided by 3. 3 2s are, so QR is 12 centimeter. I hope it's clear. Yes, now you have to find PS. So you have to take this into consideration. So PQ upon PS is equal to any other you can take, say PR upon SR. So PQ is 8 upon PS is equal to PR is 6 upon 3. So PS will be equal to 8 into 3 divided by 6. 3 2s are, 2 4s are. So it is 4 centimeter. The second part is done. Now you have to find the area. Okay. Area of triangle PQR upon area of triangle SPR. You can take any two sides. So they are equal to the square of their corresponding side. So here let's take PR square upon SR square. What is PR? 6 square and SR is 3 square. Which is 6 square is 36. 3 square is 9. So it is 4. So area of triangle PQR upon area of triangle SPR is 4:1. I hope it's clear, children. I end this video here. Please stay connected for the rest of the chapters. Till then, bye, take care and God bless.